On the left-hand side, you see a 2D image converted to a 3D mesh using an 8-bit depth map. On the right side, it's using the same image, however, it's using a 16-bit depth map instead of an 8-bit. At a glance, you might not tell the difference between the 3D mesh on the left versus the one on the right. But if you go into solid mode, you'll see that the one on the right is smoother and it doesn't have the banding issues that you can sometimes see in the one on the left. There's also more and cleaner detail, but the one on the left has more depth than the one on the right. So there is a drawback. It really depends on what your needs are. Let me show you another example. I first want to thank the community for their support and feedback, and because of you, I've been able to enhance and improve the tool, so thank you very much. Both the 8-bit and the 16-bit for this example have a depth strength of 0.5, a subdivision of 8, and a smooth factor of 1. At a glance, the 8-bit actually looks better than the 16-bit when using the inputs that we just provided. But if we wanted more detail, that's when 16-bit can look better. Let me first increase the subdivision to 10 on the 16-bit. The detail really comes out. Let me do the same for the 8-bit. The banding looks terrible. So there is some limitations in 8-bit. In summary, typically the 16-bit depth map will produce better detail in the mesh with minimal banding. But the drawback is, at least for the code that I've been developing for 16-bit, produces less depth. It seems to be flatter than the 8-bit. If you're needing to use the mesh for something like lighting in Blender, then 16-bit might be a better option. A few more things to note is, one, if you look at the side on the mesh, it doesn't look too good, and then the back side is hollow. For a little bit of background information, I'll share how I got started in doing this comparison. Here are the images that I'm using for my examples. They are all AI generated. In terms of how I'm generating the depth maps, I'm using my own tool. It's called Depth Map Batch. It can create depth maps for a directory of images, a video file, or a single image in a batch process, which could save you a lot of time, particularly if you have several different depth maps you need to generate. But you can totally generate depth maps online if you upload one at a time, or you set up a local environment in something like Comfy UI. However, I built the tool so I can keep my workflow within Blender. Let me cover a few important settings that I'm using within Depth Map Batch to generate both the 8-bit and the 16-bit depth maps. The first is the depth map style. For the 8-bit, I'm selecting close white. And for the 16-bit, I'm using the 16-bit option. And then inside of model options, I'm choosing the 1024 max resolution value instead of 512, which in almost all cases will produce better depth maps. For the depth map model, I'm using depth anything v2. And then for input method, I'm choosing image directory, which is where all of my original images are, and we'll just generate the depth maps for all the images within that directory. The second tool I'm using is called zForm. It's another one of my tools, and it will transform your 2D images and depth maps into 3D mesh. All of the options in the tool can be done manually inside of Blender using the modifiers tab and then adjusting some of the materials. However, the tool can save quite a lot of time, particularly if you're working with several different images and you're wanting to transform those images into 3D mesh. For the examples today, I'm using the directory option in the top right, and I'm opening up the directory where it has all the images, and then referencing the depth maps for those images. The way this works, it will transform all of your images to 3D mesh for the entire directory. You can change and view different images in the directory for the 3D mesh. Is leveraging Blender's timeline. In the first frame, that will be the first image, and then if you go to the right for the second frame, that will display the second image, and so on. You can just keep scrolling in the timeline to see every single image that you had in your directory converted to a 3D mesh. Alright, that's all I got.